Hello and welcome. This course will be about SvelteKit. Svelte is a front-end framework for the web. And what is a framework in this case? It's just a tool that lets you accomplish certain tasks more easily. Other front-end frameworks are Vue, Angular, and React. Unlike those other frameworks, in Svelte, you don't need to learn a new syntax or a lot of complicated concepts. If you know vanilla JavaScript, you're pretty much set. This makes it super beginner friendly. There's also no virtual DOM. The elements of the real DOM, your page, are updated very efficiently. This can make Svelte much faster than other frameworks. You might be wondering why you need a framework in the first place over using vanilla HTML and JavaScript. That solution is okay for very simple use cases. But as your site grows bigger, the files become unwieldy. This is where frameworks come to the rescue. They make very complicated things look trivial. For example, we can add transitions on everything. If you don't know anything about frameworks, don't worry. This course is right for you. The only requirement for this course is that you know HTML and some JavaScript. We'll cover some HTML, JavaScript, and CSS as we go along. If you know the basics, you're ready for Svelte. And if you're already familiar with all this, you'll still find this course helpful. Towards the end, I'm gonna show a few things that I haven't seen covered elsewhere, like themes. I would hate wasting your time, so the course will be carefully edited to keep up the pace. The idea is that you can learn everything you need to be a Svelte dev in a minimal amount of time. There will also be some animations where it makes the concepts more digestible. By the way, this is about SvelteKit. SvelteKit is essentially the same as Svelte, but with even more tools. For example, it handles the routing and allows you to do server-side rendering. But the most noticeable thing is that you can have transitions for all your pages. How's it sound? You're probably used to VS Code by now. However, you might also hear me talk about VS Codium. Codium comes from VS Code, but removes all its telemetry. Both have the exact same features. For all intents and purposes, we're talking about the same thing. Whenever I say VS Codium, it also applies to VS Code. So, open VS Codium. Then choose the Open Folder option. Just select in which folder you want your new files to reside on. I already have a folder here, but you can choose any on your machine. Any empty directory will do. You're gonna get a terminal down here. And then type the following commands. We're gonna use the Node Package Manager, or NPM for short. And we're gonna init or initiate a module. We're gonna initiate Svelte at the latest version, so add next. Then we're gonna name our app. We're gonna call it Best Site Ever. Then we're gonna get a few options here. We can create a demo app or a skeleton project. The demo app has more files by default, but we don't want this right now, so go for a skeleton project. If you know TypeScript or want to use it, you can do so right now. But we're gonna go with the first option. Now add ESLint and Prettier. We're not gonna use testing right now, so go for no. As you can see, a folder has generated here. And then Svelte gives us a few steps which follow next. First, we must cd or change into the directory we've just created. Then we must install the dependencies. npm install. This might take a minute, so be patient. Nice, it's complete. So let's see what else we should do. It tells us to initiate a Git repository. But we don't really need to do that, as it says here, optional. So we're going to go with the last one, which is to actually run the project. So we're going to input npm run dev and then the option to open it in the browser. So npm run dev -- open. Nice, it's worked. Let's check out the files that Svelte generated for us. There are a lot of things in here, but the only thing we really care about is this source folder, because it's the source for the code. In it, there's an app.html file. You might be tempted to edit this directly, but that's not how it works in Svelte, nor in any front-end framework. In front-end frameworks, you don't edit the HTML file directly, you edit components. Let's say we have a component for the title, a footer, and a card. Components will let you handle each part individually, instead of creating the entire page in one file, like you would in regular HTML. Therefore, with Svelte and other frameworks, each important block that composes the page, read component, is containerized. This is much easier to handle, especially when we start including JavaScript. Put simply, these Svelte files give different components to an empty HTML file. The HTML then displays all of these. Again, you don't edit the HTML files directly, you edit components. Let's see an example. There's a div tag that serves as a container and gets hydrated from Svelte components. One of these components is the index.svelte file in the routes folder. You can see exactly what was displayed before. Let's check that out again. Let's try to edit this. If we change this for example, hello world, we save, and then we go back to it, we see displayed hello world. Notice that I didn't need to rerun the project, it automatically did it. That's called a hot reload. But what about changing the CSS, for example, the styling? What if we wanted this text to be red? Well, we can do that. So let's go back, go down here, and we input a style tag, and then just choose any selector, for example, the H1, the title, and we input color, red, we save, and we go back to it. Yes, now it's red. You might also need to install an extension for Svelte. Go to the Extensions tab, search for Svelte, and install it. Also, even if we added Prettier in the setup, I've noticed that it doesn't work for Svelte out of the box. So click on any Svelte file, then click on Svelte down here and choose Configure Svelte Language Settings. Copy this line, save, and the formatting should work now. We keep talking about this index.svelte component, but what is it really? It's the root page of your site. Remember what we said before, the routes folder has all our pages. That means that if we add another component here, it's going to create another page. Let's try creating an about page. So about.svelte, and include some info. When you save and add about to the URL your site is running on, it will open that page. And where does this about path come from? From the component we created. Every component we create in the routes folder gets transformed into a page and uses the same name we gave it, minus the .svelte. But as you may have noticed, there is an exception, as the only component that doesn't do this is the index.svelte. Index.svelte always gets transformed into an empty path. This is by design, because it's the default page when no path was specified. Using index to access the root page would look ugly. Now, how do you access this URL? With an anchor tag, of course. You might be thinking of including the whole path in the reference, but SvelteKit already handles the routing for us. This means that whenever you're accessing your own site, you only need to specify the page, in this case /about. Perfect. You can also nest pages by adding a folder and having components inside. When you access the URL, just use the same names you gave them. If the folder has an index page, that will be the root of the path. So the folder name and nothing else. Another thing Svelte can let you do is have a common layout for all your pages. Say you want a footer or navigation bar that you want displayed in all pages, like a template. For this, you create a special page in the routes folder and call it _layout. It needs to have this name. Inside it, create the layout with the use of a special component called a slot. Like the name implies, slots are placeholders, which means that the content will go there. Now let's add a basic footer. This can be any component too. As you can see, it's showing up in all pages. One thing you may like is that in the layout page, you can not only add a styling for the elements you explicitly include. Any CSS you define here will also apply to anything inside the slot. It gets inherited. What this means is that you can have custom themes all across your app. But for now, let's only define some constant styles with a few CSS variables. Add them inside a root selector. What this does is insert the CSS at the start of every component style tag. Now set the footer background to the foreground variable we created. Let's do something similar for buttons and give them some styling. By the way, when using normal CSS, you use global selectors. Then insert the elements inside them and just use them normally. As the CSS variables we define on the layout can be accessed by any page, we can set the greeting component, which is in the index page, to have the foreground color. You can do the same for the counter if you want to. You may want to add a container to the slot component so we can style the background. When it's done, it should look something like this. This is not a CSS course, so I'm not going to go into too much detail. But I've added a few comments so you can better understand what's going on. There, we have created a few pages and used consistent styling for them. By the way, slots can also be used in regular components. For example, if we go to the greeting component and replace the paragraph by slot, then we go back and type this component as a normal HTML tag and input any element, it will be displayed right here where the slot is. This is better than passing long strings and much more versatile. Now for your homework, I want you to create your own page with any element you want, for example an H3. And if you also want to practice the layouts, style any property of that element, like the color with CSS defined in the layout, not on the page itself. Then create another page and use that element to style. Basically, create two pages and include the same HTML element in both. But instead of defining the style in both pages, define it on the layout. Alright, go ahead and give it your best shot. You might be looking at all these HTML tags and asking, well, isn't this the index page? Aren't we still editing the whole page in some way? And at the moment, you're kind of right. Pages also behave like components and include smaller components inside them. The components then get imported into the page and shown all at once. Think of it like nested components, and for readability's sake, it's better to use that approach. So I'm gonna show you how. To create a component, create any file on the source folder and make it end with .svelte. The convention is to use capital letters for the naming. Now let's cut the content from the page and include it inside the component. Go back to the page, import the component. To import the component, you need to use a script tag up here. Import it as if it were a module. For example, import greeting from relative path greeting.svelte. Be careful, the auto-imported path will be wrong more often than not. Now use the component as a self-closing HTML tag. Save and you'll see the same content. Let's add some stuff so you can better appreciate it. For example, let's add a div to contain this. Let's also add some CSS styling, like color and border radius. As you can see, all the content gets added into the page by this one HTML tag. All the clutter is just tucked away in a smaller component. You probably realized by now, but the route folder relates to pages. For real containerized components, it's better to create a separate folder, which we'll name components. Now drag the component into the new folder. When you save, it's gonna break, because the import path is relative to the page file. You could update the path to the new location, but this path is kind of nasty. A cleaner solution is to add import aliases. So go to the svelte.config.js file and import the path module. Then inside the kit object, insert a comma and add a vid object. Also add a resolve and an alias object like you see on the screen. It's a bit convoluted, I know, just bear with me. Now inside the alias object, add whatever path you want to reference and how you want to reference it. In this case, $components is how we reference it, and then we resolve the path we want to use. So /, which means the current directory, into the source folder and selecting the components folder. Notice we didn't use a slash at the end. You can add more references here if you want to, but for now, save, go back, and change this to our reference, $component/greeting. Save again, and you might need to rerun the project. Now, wherever you are, you can always reference every component this way. Going back to the browser for every simple change gets solved fast. So let me show you another trick for coding. Press Ctrl-Shift-P and select Show Browser. If you remember, Svelte told us on which URL our site was running on. If you input that here, located in Editor browser. Drag it to the right and lock it. Much better. Now that you have everything set up, it's time to solidify what you've learned. How about making your own stuff? I want you to go and create any component. It can be as simple as you want. Just use whatever HTML and CSS you know. Then add that component to the page like I showed you. I'll be waiting here with a cup of coffee. When you're done, come back and let's keep learning. In HTML files, you usually include a script tag and a source for the JavaScript file. In Svelte, you also have a script tag, but you include the logic inside the same file. As you can see, one file contains all the JavaScript, HTML, and CSS. One file contains everything. This is called a single file component. This is super helpful because it lets you bind elements in JavaScript very easily. Let's see it in action. Without a framework, whenever you want a button to do something, you normally have a button tag and reference it by its ID. As you include more elements, this becomes cumbersome. Svelte has the perfect solution for us. You can use and reference the JavaScript directly from the elements. Let's say we create a variable for a number. So let number be 4. And we want to display this on the screen. How do we reference this variable? First, we need whatever element we'll use to display it. In this case, in H4. Whenever you want to use JavaScript inside the HTML, you need to use curly brackets. Therefore, add curly brackets and just type the name of the variable you want to display. In this case, number. There, it's showing up. Svelte also lets us add the event listener directly on the element to handle events like clicks or key presses. So if we create a button and add on semicolon inside the first tag, we get a list with all the event listeners we can use. To listen for clicks, say onClick double quotes, and inside the quotes, because you're going to use JavaScript, you need curly brackets. Inside those curly brackets, you can call any JavaScript function. So let's create one ourselves and reference it there. Go back to the script tag and make any function. For example, let's make one to increment the number we used before. So number plus plus. Remember, plus plus is a shorthand for increment by 1. Lastly, reference this function on the event listener. Notice that we don't use the parentheses to call it. Now save and click the button. You can see that the number gets bigger every time you do so. What's very nice is that all of this is valid vanilla JavaScript. Other frameworks require you to learn their own syntax, and they're not as easy to use. Now let's move this counter into its own component. Just bring everything in there. That's cool and all, but what if we want to set this number from the parent, from index.svelte? That's called a prop. We can do that by going inside the component and adding export to the variable we want to access. If you're used to working with JavaScript, this might seem a bit weird, but think of it like the variable is just announcing itself and not sharing the value. As we've already assigned 4 as the value, this will be the default when no prop was specified. But we can change this value by passing a prop from the parent. Type the variable you exported in the component and give it a new value. Now save and look, the value has been updated. Every time you need to pass data from a parent to a child, use a prop. By the way, our variable was a number, but every time we input a prop, it gets passed as a string. These data types are incompatible. So to convert the string into a number, use a JavaScript expression. So curly brackets. When you do this, the number will pass directly without being converted as a string. That's the most simple fix. Talking about fixes, if you get a red underline when importing a component, go to the jsconfig.json file. And add a paths object. Inside it, specify how you want to reference. Specify the reference you used for the components, and then a /*. Then make an array with the path it's using. In this case, everything inside the source components folder. The asterisks mean that it refers to everything inside that folder. By the way, don't think I forgot about your homework. This time, I want you to go back to the component you created last class and add a prop into it. Then display the prop on the screen. You get an extra point if you add a button to update that value. Okay, now go and give it your best shot. I believe in you. There's another useful feature we still haven't covered. It's called binding. Binding allows you to, bind any property of an element to a JavaScript variable. So if either gets updated, the value will change for both. We'll see an example in just a minute. But before starting, let's center the content. For that, let's wrap the component in a container, for example a main tag. Then give it some CSS below. The easiest way to center the children is to use display grid. This lets you use another property called justify items to adjust the horizontal position. Let's try adding anything else. All the content is jammed together. We could add some margin to every element, but CSS grids allow us to have gaps between every child, in this case 1 rem, or the size of our font. With that out of the way, let's learn about bindings. Say we have a text input element, where the user can type anything. We can get this value by saying bind semicolon. We'll get a list with every type of data we can bind. Since we want the value, select value. Now we need to tell Svelte which variable to bind it to. We don't have one yet, so let's create one called user input and reference it on the bind. Nothing happens. That's because this is a string right now, and we need to reference a JavaScript variable, so curly brackets. The editor is yelling at us because we're trying to assign a string into an empty variable. So set the initial value to an empty string. This will get updated by the bindings. Now display it by including that variable in another element. Great. Now let's move this into its own component. I'm gonna call it form demo. But there's a problem. We know how to pass data from parent to child with props. But how do we pass data from the child to the parent? You need to use bindings, but in a way that resembles props. Go inside the component and export the property you want to access. Then on the parent, look at the component tag and type bind. Since the variable we exported turns into a property of the component, we can bind that property. Then we specify what we want to bind it to. So let's make another variable, which can be called the same, and bind it to the property. Let's also display it to see if it's working. Nice. Remember that you can pass any kind of data like this. Anything you export in the child component can be accessed by the parent through bindings. Also, different input types have different ways of accessing the value. For example, with checkboxes, you use bind checked. It will return a boolean. And if you have a selection group to choose between many options, you don't access the value from the options themselves. You set a value for each option and get the selected one from the parent, the select element. If you want to practice this, create any input element and bind it to a JavaScript variable. And if you also want to practice passing data from a child component to its parent, export the variable you created and bind it to another variable in the parent, then display that variable on the screen. Good luck. We have already seen how to pass data from parent to child and vice versa. For the most part, it works flawlessly. But what happens if, for example, we have nested components? I want to pass data to an ancestor or a sibling. Like, if we move all these inputs we showed last class into their own components. And for example, we try to display info from the text input into, say, the greeting component to greet us. We need to have props and binds all over the place. This can quickly become hard to manage. For this, we have something called stores. Stores, like the name says, are centralized places to store our data. So no matter where we set this data from, the data will always be accessible. How do we write a store then? You need to create a JavaScript file or TypeScript file if you're using TypeScript. It can be anywhere inside the source directory, but I'm going to create a folder so it's better organized. And inside the stores folder, I'm going to create the store itself. It can have any name, so I'm going to call it user, because we're going to store some info about the user. Inside, you need to make an import, so import writable from Svelte store. We import writable because we want to be able to edit this store. You could import readable to create read-only data, but that's not what we want here. Now declare whatever variable you need. In this case, let's make a name variable, and assign this variable to a writable function, which means that this variable can now be written to from anywhere. If you want, you can set a default value inside, for example, Peter. This variable is the one we want to access from the outside, so let's export it. This is now a store and can be accessed by any component. So let's display it on the greeting. First, we need to import whatever variable we exported on the store. Then we need to subscribe to the store. Subscribing means that our component will get notified when the store value changes and will update accordingly. There is a subscribe method that takes a callback function to use the stored value, but that's a lot of boilerplate. It would be nice if we could simply use this variable directly, and turns out we can. We only need to write the variable and prepend a $sign to it. That's it. We're using the stored value. Now, we're only displaying the default value. We're not actually using the input. So go to the component containing the input, and instead of binding the value to a local JavaScript variable, we can bind it to the store. Now we can get rid of this. Okay, I don't like this being bound directly to our input. I'd like to write something first, and only display it after I press a button. So let's add a button, add back the variable because we need it to be private to this component, and let's add an onClick event to our button. We're going to give it a setName function and create that function. Now we want to update the name on the store with the value that's on the local component. And how do we access that value? $sign and the name of the variable. Yes, we're not limited to accessing it from the HTML. We can use the shorthand on the script tag too. So let's assign the input name to the store. The name now gets set every time we click the button. There's also a way to skip having a function on the script tag. We can have these instructions directly on the onClick property with the help of an arrow function. In case you don't know about it, arrow functions are basically normal functions, but without the name and more compact. You might have seen them on callbacks before. So let's use an arrow function, and inside type the operation we want it to do. In this case, assign the input name to the store. And it works the same. You can do this anywhere to avoid the boilerplate. Don't forget you can avoid relative paths by using import aliases. I declare them on the JS config. Also, you're not limited to one variable per store file. You can have multiple variables and import whatever you need. Let's practice using stores. Create your own store file anywhere you want with any name. Then export a store and use it on any component. Extra points if you update the value. Right now, the value we're setting for the store will be forgotten every time we reload the page. We could have a backend to remember this, but for some things, it's better to have the client do it. So, to remember this value, we need to go back to the store and set the writable function to a local storage item. Remember, local storage is where the browser stores key-value pairs, where it stores persistent data. Let's get an item by specifying a key. This can have any name, as it's created by us. We're getting it, but it hasn't been created yet, so the value will be null. We can get a default value instead by saying or repeater. So the writable will be equal to either the value from this key or our default value. Then, to actually make this item, we need to set the value. We need to set this every time the value changes, so we gotta subscribe to this variable. Sadly, this is the same file our store is defined on, so we can't say $name. We have to subscribe to it with a method, and we include a callback function. The callback will take an argument, which can have any name. No matter what you call it, it's referring to the store's current value. And when that value changes, we want it to set the item. So local storage set item. And inside that, for the first argument, we state the name of the key we want to create, and then the value we want to give it. In this case, the current value of the store, so the name we used for the argument. If you save and run this, it still won't work. We need one last thing, and that is to import the browser from the app's environment. Then you add browser ampersand before these two statements. So this only gets executed if the code is running in a browser and not by itself. It may sound a bit confusing right now, but just know that you need to use browser before accessing the local storage. Now save, and the data should be persistent, even if you reload the page. As you already know, you can use HTML elements on any Svelte component. But what if I told you that you can also include logic when rendering those elements? For example, you can use an if block to render something conditionally. So anything inside the block will only show up if this condition is met. So if this expression is equal to true. Say we only want to render the form data when the counter is bigger than 10. So let's put it inside the if block. Let's also bind the count so it's accessible from a variable. Now let's use it on the if block. It's used just like an if statement. The expression will be evaluated, and if it's true, the form component will be displayed. At first, it won't be there, but when the count goes over 10, it will show up. You can also use else and else if blocks. For example, if the count is lower than 10 but bigger than 7, we prompt the user to click some more. And if none of these are true, we tell the user to click the button. You can also loop through data to display something multiple times. Let's look back at this select group we made before. Right now, it's manageable, but including more options is very repetitive and clutters our file. We can avoid this with each blocks. Each blocks can loop through iterable items, like arrays. Say we have an array of strings with all the colors we want to display. On the each block, we iterate over them by saying each, the name of the array, so colors, and then as, and how we want to call each individual item of this array. It can have any name, so I'm going to call it color. Then move all these options into the each block, and only leave one. Our array's length is 5, so it will render 5 times. Now, every time it displays, we want it to show each individual color, so use color inside a JavaScript expression. As you can see, we've greatly simplified our code. You can also get the iteration number by saying comma and naming the iterator. There's also a key block, which just re-renders the elements inside when the condition changes. This suits quite well for animations. We're gonna see more about animations in another class. Lastly, we have the await block. This is for handling promises. In other words, for when we're fetching data. To give you an example, let's make a function to fetch an external API. We'll make a fetch request to that URL and assign it to a variable. As we don't know how much the server will take to give us the data, we gotta use await. And because we're using await, we have to make this an async function. Now we make another variable, await for the last value, and turn it into usable text. Then return that value. Now, this whole function still returns a promise, not the data itself. That's why the await block exists. We can await for the promise to be fulfilled and use a then block to display the fulfilled promise. So inside the await, we put something to be displayed while it's still loading. And then, when it's already loaded, we display the number. The keyword next to the then can have any name. We're just naming our data, the fulfilled promise. If there's an error, we can also catch it and display something. By the way, all these logic blocks can also be nested. It can get pretty complex. Some practice wouldn't hurt now. Go to any component, create any condition, and evaluate it with an if block to render an element conditionally. You can also try and create an array and loop through it with an each block. And if you're feeling a bit crazy today, make an async function to fetch some data. Then use an await block and display that data. This time, we're going to learn something specific to SvelteKit. Last class, we fetched an API. This function gets called when we reload the page. The thing is that it only starts to load when the component has already rendered. We can optimize it by loading it even before the component shows up. So by the time it's displayed on the screen, the data might already be there. To do this, we can create a second script tag. Yes, you can do that, and use a context module. This allows the code to run outside the component before it's even mounted. But notice that we don't do it in the component, we do it on the page. This can't be done in components. We need to do it in the page, and then pass the data through props. Inside, we make an async function, which we must call load, and then we must export it. As an argument, it can take a fetch object. It's used the same way as the fetch on the counter. We fetch the URL, await it, and assign it to a variable. Then we await that value, turn it into a JSON object, and assign it to another variable. Now this function can return a prop for our component. So return a props object, then give it the prop any name, and assign it a value. In this case, the number from the JSON object we fetched. Now you can create a variable with the same name as the prop. Give it any initial value, export it, and just use the variable. Then pass it like any other prop. Also, since the property and the variable are called the same, we can just type it once inside the curly brackets. That's the same as saying fetch number is equal to fetch number. You don't even need the await block. Right now, we might not notice the difference since the component loads so fast, but it might come in handy as your application grows. It might not be the best option in all cases, so beware. One more thing. You can also run this app on your phone right now. Just open the terminal again, terminate the process with Ctrl+C, and then type npm run dev -- and host. Assuming you're not using a firewall, you should be able to use the URL that's labeled network. Open your phone, type that URL in the browser, and the site should show up. We've managed to fetch some data before the component is mounted, before it's even loaded, but we can also run code when the component mounts, or when it unmounts, so when it disappears. These are called Lifecycle Hooks. To demonstrate this, instead of finding the form demo's f-block to the counter, I'll use a checkbox. This f-block is mounting and unmounting the component. We can hook to these events and execute some code when they happen. Let's import unmount from Svelte. Let's add a count for how many times we mounted this component. And display it on the screen. So on the script tag, you say that every time we mount this, we want to increment the count. It works. You can do this for all other lifecycle events. We mentioned animations before. In Svelte, you can add transitions when a component shows up or disappears. For example, on this forum demo right here. You might think that there's a special property that you can type on the component tag. But no, you need to go to the component itself. Then you import a transition from Svelte. I'm going to use scale. There are others like fly, fade, blur, and slide. As you can't use transitions in components directly, type transition on the HTML element that's containing everything. You can now say transition and specify which transition to use. In this case, scale. Now let's do the same for the text. So import the transition and use it on the p tag. It's very jumpy. That's because they're happening simultaneously. We needed to wait for the other transition to end. In other words, we need a delay bigger than the form's transition duration. Go back to the form and treat the transition like a property. Inside, you need an object inside a JavaScript expression. So, double curly brackets. You can specify a delay and duration inside. So let's set a duration of 300, which means 300 milliseconds. And on the text, do the same, but set a delay equal to or bigger than the duration we used. It looks okay when appearing, but not when disappearing. In fact, I don't want a transition when it disappears, only when it shows up. So instead of saying transition here, I type in. And it looks awesome. If I wanted the opposite, I would type out. What you can also do in SvelteKit is add page transitions. Remember that layout page we created before? Turns out we can make a transition that applies to every page. We could add it all here, but it will be cleaner if we add a page transition component. Inside, import whatever transition you want to use. And export a variable called URL. This URL will be the page route we're on. We're going to get that value from the layout with a prop, so we have to export it. You'll see why we need this in just a minute. Now add any container element and specify an in and out transition. Let's set a duration for the out transition. We also need a delay on the in transition. That's equal to or bigger than the out, so they don't happen simultaneously. This will be a container element for all the pages, so we need the content to go inside this. And how do we do that again? With a slot. Now, remember when we talked about logic blocks? I mentioned a key block, which mounts and unmounts a component when a variable changes. This is important because when the component is mounted and unmounted, it will start whatever transition we set. In this case, we want a transition to play whenever the route changes. So our key will be the URL. Whenever the URL changes, the transition will play. Now, import the page transition component on the layout. And use it to wrap the slot. The pages are passing through as a slot into the page transition and getting handled by that component. Now we need a way to pass the URL into the page transition for the key to re-render the component whenever the route changes. But we need to do it before the page loads to avoid jankiness. Again, how do we load JavaScript before the components are rendered? We need a context module script tag. And inside, export an async function called load. but instead of having fetch as an argument, we use URL inside an object. Then we simply return a prop and just have the URL be the prop. On the normal script tag, we make that URL variable and export it. Finally, we use it as a prop on the page transition. As the property and value are the same, we type it only once. Looks nice, but I want other animation. So I go back to the component, import another transition, and replace the one we were using. This fly transition can take two more values, x and y, to move a fixed amount of pixels on the x and y axis. Much better. Having consistent styling for your whole app is nice. But what about having dynamic styles that you can change with JavaScript variables? You can do this with style directives on the HTML element containing the components. For example, style semicolon and declare a CSS variable, like how we did with the background. Just that you need to remove the colon and the semicolon and surround the value with quotes. So again, we have the style directive, then the double dash means you're gonna declare a CSS variable. Finally, you give the value like any other property, with an equal sign and quotes. This is the same as setting a CSS variable in the style tag. What this allows you to do is set the value in the script tag. This might seem like a lot of hassle for little to no gain, but now the styling possibilities are endless. For example, we can make themes. For this, let's create another store, which we'll call themes. We're gonna import writable from Svelte store. Now we're gonna create a variable called themes, which will be an array that holds all our themes. Every theme will be an object with a set of properties. It will have a name and all the CSS variables we need. To make those variables, just give it whatever name you want and then the value, in this case a color you want to give it. I'm gonna copy all the variables we created before, paste them here, and name this theme Octopus. And let's create another theme. Since this is a JavaScript file, you won't get a nice color picker in the editor, so just search for a color picker on the internet, or use a tool like gpick. If you're lazy, you can just type red or blue, since these are essentially CSS values. When you have all your colors, just paste them on each variable. The names of these properties must be consistent across all themes. We have our themes. Let's export them so we can get a list with their names later. Now we're gonna make a store to set which theme we're using. So export let selected theme and writable to make it a store. And I want the octopus theme to be the default. I also want this to be persistent, so the theme remains even if the user refreshes the page. Can you remember how to do this? Try to remember the class about stores. We import the browser from the app's environment. and use it before accessing the local storage. And we get an item from the local storage, which we'll call theme. If the value is absent, we'll use octopus. And since we're getting a local storage item, we also have to set it. Subscribe to the store so that when it changes, we can use the local storage to set the item. We'll set the theme item to have the current value of the store. Lastly, we need the actual theme we're using. We can't get this directly, so we need a function. Making a function and then calling it is not very clean for this. So let's make an arrow function and assign it to a variable. The function will return the theme in just a second. Our theme is an object from the themes array, so first we have to loop through the array. In JavaScript, there's an easy way to loop through arrays with for off. So, for every item of the array, name the item whatever you want as a variable. For every theme of this array, if the name of the theme is equal to the selected theme, we want to return that theme. So, return that object with all the properties. Now, because the selected theme is a store, you need to use get to get the value, instead of getting this writable function. So also import get and surround the selected theme with it. Finally, export this variable. Now you can import these only layout, so import the theme and the selected theme. Then on the style directives, you can input each of these variables. Inside a JavaScript expression, call the theme as a function and get the object value that corresponds to each property. Since it might be empty in some cases, you add this question mark. After that, move this footer into the main tag so it inherits all the styling. And use a key outside that main tag to re-render the page when a theme changes. And what's going to be our key? The store with the selected theme. The last thing you have to do is make the theme selectable. So for example, if we go to our select group from the form, we import the themes and the selected theme. Then we bind the value of the selection to the selected theme, so it sets it. Then for each of the themes, we get the name and also use it as a value. Now we can select the themes. Alright. We've been opening it with a command, but what if we want the files? For that, we must build the project. Type npm run build. Under the Svelte folder, you have a ton of files. The output is what we generated. This is our site. But this can't be opened directly. You'll need to find a host. Many hosts don't accept files like this though. So let's make it easier for them. Let's make a static site that has different HTML files for every route. To do that, go to the svelte.config.js and add an adapter. We need the static adapter, which you might need to install. So npm install and what you want to install. Then specify that you want to use it, on the config. Also specify where you want to output all these. I'm going to tell it to create a dist folder and to avoid compressing our files, and set the pre-render to true. When you build it now, there will be an HTML file for every route. This is now a static site. You still can't open it directly though. You either need to find a host or preview it with npm run preview. You can remove a lot of CSS clutter by using SCSS. Go to the Svelte config file and add preprocess. Now you can go to any style tag and say lang SCSS. And instead of having a global selector on every element of the layout, you can say global up here. Now all of these are global. It's literally the same as CSS, but with cleaner syntax. When adding event listeners, you can use arguments by having an arrow function and using the argument. Now you can get the event target by having any random argument name, like E for event. And on the function, let's accept that argument and log the event. As you can see, it's an object with a huge amount of properties. The event target is the element itself, and you can change anything about it by accessing it like this. Though I don't recommend doing this if you can avoid it. There are also special Svelte tags. Just use Svelte as a component, add a colon, and you'll get a lot of options. For example, using Svelte window will let you get the document window and bind any property to a variable. Congratulations! You now know how to use Svelte. You've learned arguably the best frontend framework out there, and you're ready to make your own sites. In fact, I recommend starting your own project. Make something really simple and start building up from it. Just make your best attempt, and if you get stuck, you can watch my videos again or head to the official documentation. Sounds scary, but it's very readable and super simple. So start a new project or polish one you've been making with what you've learned here. When you're satisfied, the next step for upgrading your skills should be to learn Git, so you can share code with other developers like you. If you can, try to upload your Svelte project on a platform like GitLab. I would love to see your code. Okay, good luck and stay strong. I believe in you.